Welcome to our lesson on measurement 1, meaning we will still have to study measurement 2 somewhere in the course of your studies, and the exact place you will study measurement 2 would be in form 2, whereby we will make a continuation on the same. So in measurement 1, we are actually, it's somehow a very wide topic because there are wide concepts we are supposed to study. Then in measurement 2, it is just a continuation of this, so it's not going to be too much long. So now, in measurement 1, we are going to see, first of all, what is measurement, what are we measuring, and why, and how do we measure. That is what we are going to discuss here. First of all, we need to know what is measurement. So I hope you can see that measurement refers to the process of finding the size of a physical quantity. The process of finding the size of a physical quantity. And there are very many physical quantities that we are going to see. Now, after measuring, you are supposed to present your data with what we call units. For example, if you want to measure the weight of a body, you will give us the physical quantity with certain units like 100 newtons. If it is mass, you will give us like 10 kilograms. So that is what is meant actually by measurement. The units I'm talking about is what the scientists all over the world, they are calling it the international systems, but because it's done in French, it is known as Système International de Units. So it is shortened to be SI units. So that is it. So after every physical quantity, it has their own SI units. That is a fact. So because if you just measure using your own, then scientists do not agree. So they have to come up with a common units of measurement. For example, if it is about length, we know very well you can measure length in centimeters, meters, but there must be agreed unit. We call it a SI unit. We are going to see all this. Now, why was it so necessary that the scientists had to come up with SI units? Why did they have to establish SI units? We have two main reasons why SI units were established. Number one, to have international uniformity among scientists. A scientist in Africa, Asia, America, and Europe, all of them, they agree because of international system of units. To avoid confusion among scientists, if we are dealing with seconds as the SI unit of time, everybody else is dealing with the same, so there is no confusion. So that is the role of SI units, or why SI units were being established. We have two types of physical quantities. We have what we call basic physical quantities, also known as fundamental physical quantities. Then we have what we call derived physical quantities. But let's look at the basic. Basic are always 7 in number, and you are supposed, we just obtain the basic physical quantities through measurement. These are quantities that cannot be obtained from other physical quantities. They are obtained from measurement or through measurements. There are 7 basic physical quantities according to the international system of units. They are as shown below. Look at this. This table is showing us 7 basic physical quantity. We have length, we have mass, we have time, we have electric currents, thermodynamic temperature, luminous intensity, then amount of substance. So we have the SI unit and we have the symbol of the SI unit. So whenever you ask about the SI unit, don't give the symbol, give the SI unit. But when you are doing a calculation, you will realize that you will just be using the symbol to maybe illustrate time, like 10 seconds. So you will be writing 10s. But when someone asks you about the SI unit, you give the whole name. So length, the SI unit is meter, and the symbol is small m. Mass, the SI unit is kilogram, and the symbol is kg. Time is second, the symbol is small s. Electric current is ampere. Take it very serious. It is capital A. Thermodynamic temperature, or simply temperature, Kelvin, capital K. Luminous intensity, candela, it is C, capital C, small d. Amount of substance, mole, MOL, is the symbol of mole. So that is it. Those are the 7 basic physical quantities that you are supposed to know. This one are the quantities that will later on make us, derive other quantities, which we shall be calling them derived quantities. So that is it. Now, these derived quantities, derived physical quantities, they are only obtained through multiplication or division of what? Of other physical quantities. For example, area, if you want to get area, this length times width, for example, so it is a derived. You multiply. Volume, you multiply still. Work is a derived quantity. Density is a derived quantity. Momentum is a derived quantity. Pressure is a derived quantity, and many others. As long as you have to carry out some calculation like multiplication or division, whatever you are obtaining is a derived physical quantity. There's an exercise here. I would like you to do it. Then you see if you can, answer them. So identify the mistakes or a mistake in the following SI units, and hence write them correctly. I'll do the first two for you. The rest you will do it. You will identify the mistake. Then after identifying the mistake, you correct it. The first one, amperes, and you have been given the symbol of amperes as small letter A. So the mistake is not small letter A. It should be a capital letter A. So that's the mistake. Candela, it should be capital C, small d. That is it. Now proceed with the meters, Kelvin, seconds, kilograms, pascals, newtons. Find the mistake in each case. You can go back to our previous slide and check on it. You will be able to get guided on what are the mistakes done over here. So that is it. Still, we continue with our exercise. There are 2 types of physical quantities, basic and derived quantities. State the difference between the two. State the difference between the two. I think I gave the difference very well. If you have forgotten, refer back to your video, check the difference. Then you are told to complete the table. In fact, it's just the table we had in our previous slide. I just wrapped the SI unit and the symbol. But now, the new thing here I would like you to know is the derived quantity. For example, length. Length can give us a derived quantity like area and volume. Mass can give us a derived quantity like density, because density is given by a mass of a volume. Then and many others like electric current. Current can give you resistance, but now it's upon those who have done other topics beyond here. But for you now, because you are just, if you are in Form 1, you can answer the first column and the second one. This other one is done by someone who has gone beyond Form 1, because that person knows where to use amount of substance, where to use temperature, you see. So that is it. Another question here: why is it necessary to establish SI unit, or why was it? Let's do it as past tense because it was done many years ago. Why was it necessary to establish SI units? I gave two reasons for the establishment of SI units. I believe you have not forgotten it. So from here, I want us to see now the measurement of basic physical quantities. We are starting with length. It is the measure of distance between 2 points. When you measure a length or a distance, distance between 2 points, for example, the length of your classroom, then that one is a length. The distance will give you a length. The breadth is a length. The diameter is a length. Height is a length. Depth is a length. Anything that, as long as it's about the distance, it gives you length. So let's move on. Length, apart from saying that the SI unit of length is meters, we also have what we call the multiples and sub-multiples of what? Of length. So now, not of length, of meter, because we are supposed to convert from meters to centimeters to kilometers and all those. This table summarizes it for you. 1 kilometer is 1,000 meters. 1 hectometer is 100 meters. 1 decameter is 10 millimeters. 1 meter is 10 decimeters. 1 meter is 100 centimeters. 1 meter is 1,000 millimeters. 1 meter is 1,000,000 micrometers. You can develop a song, you know, something that can enable you, you know, remember this. Someone was saying King Herod do maths during class morning, but I think, you know, can you create yours? Just come up with yours that can enable you, you know, you can remember it very well. That was done some very many years ago by a primary maths teacher. So now you can also develop yours, then will enable you to remember these things. Or you don't have to, just remember it the way it is. Exercise here for you. You know, after everything we are supposed to come up with an exercise, and you are told convert the following into SI units. 100 kilometer, convert 0.00025 millimeters, 0.01 hectometers, 25 millimeters, 25 micrometers. Then in brackets I've given you the answers. So now the challenge is this: convert the following into SI units. So you are supposed to see kilometers, then these things are talking about length. So the SI unit of length is meter. So in short, convert all these into meters. The answers are with the brackets. So just do it. If you cannot get what is in the bracket, then there is something you've gone wrong. Just try it. Give a trial. Now, I want us to see how length is being measured. Measured. We can measure length by estimation, and we can measure it accurately by use of measuring instruments. So that is it. So there are two methods, by estimation and accurate measurement. So we have four of them, 4 instruments that we can use to measure length accurately. Then from there, we will now see how each is being used. We have meter rule and a half meter rule. We have tape measure. Tape measure is used to measure very long length. For example, if you want to measure the length of a soccer field or just a very long length. Then we have another one here known as vernier calipers, used to measure a short length, e.g. thickness of a textbook or diameter of a measuring cylinder. We have micrometer screw gauge, used to measure a very short length, e.g. diameter of a wire. So those are the ones, 4 of them. But in this case, we will only study about meter rule and half meter rules together with the tape measures. Vernier calipers and micrometer screw gauge, we will discuss them when we shall be dealing with the measurement too. But know where to use the vernier caliper and know where to use the micrometer screw gauge. So let's meet in our next lesson, in our next video, such that now we can discuss how we use how we use meter rule and how we use tape measures. We will also see the types, various types of tape measures. God bless you.